So folks, we have one more definition of our tangent plane. And in class, we'll show how this definition is related to the other definition we gave. I think that this formulation of the tangent plane is a little bit easier to work with, but on the flip side, it's a little bit harder to see how this is related to the original ideas of normal vectors to the plane. So the idea is if we've got a surface where we've solved explicitly for the dependent variable z, as long as that surface is differentiable at the point AB, then we can go ahead and construct the equation of the tangent plane to that surface. And so here's our definition of that. This should look a little bit similar to your planes where we've got a point A, B, and then f of AB, there's the point, and then we've got the x components being multiplied by some factor and the y components being multiplied by some factor. And those should look a little bit familiar. You would kind of expect them to be related to partial derivatives because of what we saw above here when our original definition was related to this gradient vector of the surface when we were thinking of the surface as a slice of something in R4. So let's go ahead and actually compute this, and this is really just sort of plug and chug in my opinion. Once you've already got a surface explicitly given in the form z equals, in this case, 32 minus 3x squared minus 4y squared, we just follow the formula. So we're going to need to compute some partial derivatives. So if we compute partial f partial x, that would be minus 6x. And if we evaluate that partial derivative at the point 2, 1, that would be negative 6 times 2, which is equal to negative 12. And if we compute the partial derivative with respect to y, I get that that is minus 8y. And if we evaluate that at the ordered pair a comma b, so a comma b is those first two coordinates, right? So we'd have to evaluate this at 2, 1. That comes out to be negative 8 times 1, or negative 8. Now that we've got that, we just finish this out. So we say that our equation of the tangent plane is z is equal to negative 12 times x minus 2 minus 8 times y minus 1 plus 16. And there we've got the equation of the tangent plane. Very straightforward as long as this is already explicitly solved for the variable z. So if we look back at this example up here, we could have used that version of the tangent plane, but what we'd have to do is we'd have to solve this explicitly for z first, and then we could use that definition. And you could see how potentially that's problematic, because if we were to solve this for z, we'd get a plus or minus, and we'd have to be far more careful in that case. So just to summarize what we've learned here, folks, we've got two different definitions of a tangent plane. And if we think of the surface explicitly in the form z equals f of x, y, then the equation of the tangent plane at, I should have added there, at the point AB, f of AB, is given by z equals f of x of AB times x minus a plus f of y of AB times times y minus b plus f of AB. But if we were given the surface implicitly, in which case we think of it in the form f of x, y, z equals 0. So it's a function of 3 independent variables. Its graph lives in 4 space, but we just take the slice for that 4th dimensional dependent variable is 0. Then we can give the equation of the tangent plane this way. It would be the gradient of f evaluated at a, b, c, and we're going to dot that with x minus a, y minus b, z minus c, and we want to force that to be 0. This is giving us all of the vectors with a tail at this point that are orthogonal to what we're claiming the normal vector is. So folks, it's important that you realize that there are these two different definitions, and know that some cases it's easier to use one formulation, some cases it's easier to use the other. And the thing to really be careful of is that you don't crisscross these two definitions somehow. I've seen students combine bits of each of them. Okay? So for that, to practice that, what I'd like you to do here is you're going to try this one. I've already given you the solution to it. And go ahead and find the equation of the tangent plane at this order triplet right here, and use both of the two definitions to come up with it. That finishes out this pre-work, folks. If you have any questions, please let me know, and I will see you in class.